Find the circumference of the inscribed green circle. Label points J, H, G, C, B, D, E, and F. Since J, H, G, C is a square, this implies that line G, H equals to line C, G. It is because the side lengths of a square are equal. It means that CE equals to CG minus EG, which equals to 1 unit. Locate the center O of the circle. Join line B, O and line C, D, each of which equals to the radius, R of the circle. It implies that DE equals CE minus CD, which equals 1 minus R. Also, join E, O, which is an angular bisector of angle DEF. It implies that now, from triangle EGH and let angle GEH equals beta. It signify that angle DEO equals 180 degrees minus half of beta, which equals to 90 degrees minus half of beta. Consider triangle DOE. By Pythagoras' theorem, the square of EO equals the sum of the square of DO and the square of DE, which equals to the square of R and the square of 1 minus R. Find the square root of the equation and we have that EO equals the square root of square of R plus the square of 1 minus R. By trigonometric identity, DO divided by EO equals sine 90 degrees minus half beta, which equals to R divided by the square root of the square of R plus the square of 1 minus R. We call it equation 2. But sine 90 degrees minus half of beta equals cosine half of beta. Substituted in equation 2. It implies that R divided by the square root of the square of R plus the square of 1 minus R equals cosine half of beta. We call it equation X. From triangle HEG. By Pythagoras' theorem, the square of HE equals the sum of the square of GE and the square of HG. Substitute values. We have that the square of HE equals the sum of the square of 4 and the square of 3, which equals 225. Take the square root of the equation and we have that HE equals the square root of 25, which equals to 5. Thus, cosine beta equals GE divided by HE, which equals to 3 divided by 5. By trigonometric identity, cosine beta equals the product of 2 and cosine square half of beta minus 1. Substitute value of beta. This implies that the product of 2 and cosine square half of beta minus 1 equals 3 divided by 5. It implies that the product of 2 and cosine square half of beta equals the sum of 3 divided by 5 and 1, which equals to 8 divided by 5. Divide the equation by 2. We have that cosine square half of beta equals 4 divided by 5. Take the square root of the equation. Thus, cosine half of beta equals the square root of 4 divided by 5, which equals to 2 divided by the square root of 5. Substitute in equation x. It implies that r divided by the square root of the sum of the square of r and the square of 1 minus the square of r, which equals to 2 divided by the square root of 5. Square the equation to obtain a new equation as shown on the screen. Cross multiply. Simplify the equation further, and we have that the sum of 4 times the square of r and 4 minus 8 times r plus 4 times the square of r equals to the sum of 8 times the square of r and 4 minus 8 times r. It signifies that 5 times the square of r equals 8 times the square of r plus 4 minus 8 times r. Factorize and simplify. We have that the product of r minus 2 and 3 times r minus 2 equals to 0. Thus, r minus 2 equals 0, or 3 times r minus 2 equals 0. It implies that r equals to 2, or r equals to 2 divided by 3. Since the length of line BO equals to r, and r is less than the length of line CE, which equals 1 unit, it implies that r is not equals 2 units. Thus, r equals 2 divided by 3 units. Therefore, the circumference of the circle equals the product of 2 and pi times r, which equals to the product of 4 and pi, all divided by 3. In units. After substitution and simplification of values.